Hello? Alright. This, for some reason, my recording got cut off a little bit. So this will be part 2 of polynomials. So I will do another example of, of applying the Vieta's relations. Alright. Let's say, x to the 4th plus some coefficient a, x squared plus bx plus c is equal to 0, and -1, 2, and 3 are 3 roots of this function. So based on our Vieta's formula, notice that there's a 0 before a to the 3rd, so that means the sum of roots is equal to 0. So that's how we can find the 4th root. 1 plus 2 plus 3 plus, let's call the 4th root r is equal to 0. Move 1 to the other side and subtract 5, so r is equal to -4. Next, since I want to find what a, b, and c are, remember a is equal to the sum of combinations of 2 roots. I should have 6 sums, since 4 combination 2 is equal to 6. I should have 6 terms. So let's do this. -1 times -1 times -4 plus 2 times -4 plus 3 times -4 plus plus -1 times plus -1 times 2 plus -1 times 3 plus 2 times 3. This will be equal to 4 plus -8 minus 12 minus 2 minus 3 plus 6, which will then be equal to okay, so let's do this. These cancel out. -15. So a is equal to -15. Next we want to find b. And as you know, based on the Vieta's relations, b is the sum of combinations of 3 roots. And 4 combination 3 is equal to 4. So what will happen is -1 times -4 times 2 plus -1 times -4 times 3 plus 2 times 3 times -4 plus 2 times 3 times -1. So we're in each of these terms we're omitting 1 root. So just to make sure, since our root is -1, -4, 2, 3, this one omits 3, this one omits 2, omits -1, omits -4. So this will be equal to -8 plus 12 plus -24 minus 6, which will be equal to -10. Negative of -10, so positive 10. finally the last term will be just a product of the roots, and this time it's positive, so 2 times 3 times -4 times -1 is equal to 24, and that's it. C is equal to 24. Alright, so transforming polynomials. Okay. There's 3 types of transformations I want to go over. One of them is, let's say that I want, let's say f of x has roots. F of x has roots r1, r2, r3, rn. However, I want a function with the root 1 over r1, 1 over r2, 1 over rn. So this first transformation will be how to find the reciprocal of the roots. The next transformation we'll work on is finding the a factor multiplied by the roots, a function which has a factor multiplied by the roots, and a sum added to the root for the last one. So since f of r1 is equal to 0, f of r is equal to 0, we want a function where f of 1 over r is equal to 0. This function can be given by 1 over f is equal to 1 over x, because if I plug in 1 over x equals 1 over r, then that will end up being the same thing as f of 1 over r equal to f of r equals to 0. But one problem is that f of 1 over x is not a polynomial. So what will end up happening is we'll have to multiply by x to the nth power times f of 1 over x, which we'll just rewrite as g of x. And let me give you an example. So let's say I want to find the roots of a polynomial, a function with the reciprocal of the root polynomial, x squared minus x to the 4th minus 3x squared plus x minus 9. So I want to take a function. I want to make the transformation f of 1 over x. X to the 4th times f of 1 over x. Jeez. So this will be x to the 4th times times 1 over x to the 4th minus 3 over x squared plus 1 over x minus 9. This will be equal to minus 9 x to the 4th plus 1 x to the 3rd minus 3 x squared plus 0 x plus 1. So what ended up happening is that the terms just switched around. The coefficients of the terms kind of switched around compared to the original one. This is sometimes I've seen this happen 3 times on I've seen this happen to a question like this 2 times on actually 3 times in competition. I believe it happened on both the AMC 12A, 12B this year, and it was around like problem 15 to 20 range difficulty wise. And it also happened in the Stanford math tournament for the algebra, for the guts round. So just memorizing that a polynomial with the reciprocal roots will have the coefficients switch around, allowed me to solve this problem in literally like 10 seconds. So that was awesome. That's pretty epic. Alright, let's say f of x. Once again, f of x is an nth degree polynomial, except this time I want the roots 2r. So then I can make the transformation f of x over 2. Just plugging in x equals 2r will end up with will give me f of r, which is equal to 0. So let me do an example. Let's say I want a polynomial whose roots are half of those let's give a polynomial f of x is equal to 5x to the 4th plus 12x to the 3rd plus 8x squared minus 6x minus 1. Let's say we want the roots that are twice those of this one. Plugging in f of x over 2 will give me 5 over 16 x to the 4th plus 3 over 2 x to the 3rd plus 2 x squared minus 3x minus 1. And this, the roots for this polynomial will be twice as the original. Moving on. Let's say I want a root equation whose roots are c greater. So, as before, I think you guys have a basic idea. F of x plus c will give x of x minus c will give a polynomial with roots r plus c. So that's it for transformation of polynomials. The last thing I'm going to want to look at is the phenomenon of Newton sums. So let's say I want the sum of the so there's a formula where let's call sk the sum of the roots to the kth power. So that's r to the k plus r2 to the k or n to the k. Using the general form of the polynomial, an times s1 plus an minus 1 is equal to 0. An times s2 plus an minus 1 s1 plus 2 an minus 2 equals 0, and so forth. The general form of this is an times s to n plus an minus 1 Sn minus 1 plus all the way down to 4 a naught, n a naught, sorry, is equal to 0 for general form. And it's impossible for Sn to have a integer n that's less than 0. The n over here, an easier way to think of the n over here is just the sum of the roots to the 0th power. And since there's n roots, it's just n times 1, which is n. I hope that helps. I used to get confused by the last part, but then I realized this connection later on, and it was really helpful for me in memorizing the Newton sums formula, because this also shows up in a lot of AMC tests, AMC, AIM, and various college tests. Alright, let's prove this phenomenon. Let's say I want to sum, let's do an example. Let's say I want to sum cubes of roots. I want to find S3 for the polynomial 2x to the 4th plus 3x to the 3rd plus x squared minus 4x minus 4. So 2 times, we have to go step by step. So 2 times S1, the sum of roots. I expect it to be negative 3 plus 3. Oh wait, no. Negative 3/2, since this has to be monic. So I would divide by 2 for the roots to be equal to 0. So S1 is equal to negative 3 over 2 as expected. Next, to find S2, I want 2 times, dang it, S2 plus 3 times negative 3 over 2 plus 2 times 1 is equal to 0. So I find that S2 is equal to 13 over 2. Sorry. 9 over 2. Oh no, 5 over 2. Because adding this to both sides will be 9 over 2, and then I'm subtracting 4 over 2. 2s2 would be equal to that, so divide both sides by 2. Get s2 is equal to 5 over 4. One more step. Ooh, nice. Very intimidating. Very exciting. 2s3 plus 3 times s2 s2 plus negative 3 over 2 times 1 plus 3 times negative 4 equal to 0. So S3 would be equal to adding there's a chance I might silly, but I'm sure, and when solving this, but I'm sure you guys get the main idea. Equal to 4 plus 4 minus 3, which is equal to 1, plus 3 over 2. Wait. Oh, I mean, I made a mistake. Sorry. Five over 4. So it's 3 times 5 over 4, right? Minus 15 over 4 plus 12, because 3 times negative 4, this is just negative 12 over 2, and I won't simplify that here since we're pretty much out of time. So that's the idea of Newton's sums, and now I'm just going to go over the proof really quickly. So let's just rewrite the function f of r1, where f of ri, where I is any one of the 1. I is an integer from 1 to n, which is equal to 0. F of, so then a, multiplying each polynomial by, so n to the, oh my gosh, this is kill. My whiteboard is killing me, sorry for my complaint. Rn to the plus n minus 1 to the ri to n minus 1. You get the point. A0. Multiplying each of these by r to the k minus r to the k minus n will give us a n times r1 to the k plus a0 r to the k minus n. And this will, I'll just write out all the different polynomials for all the different roots. This is equal to 0. And then an r n to the k plus a0 r k minus n equal to 0. So this will adding these will adding all these together will give us the Newton sums. So it'll be will give us sk, since it's a sum of all the roots to the kth power, plus a 0 sk minus n, and I find that sk minus n is equal to 0 when k is equal to n. So that's how we derive the general form of Newton's sums. I hope you understand it and found this video interesting. Thank you for listening. I hope to see you next time. Goodbye.